The purpose of this session is to discuss what other improvements can we do to PowerNap. As we all know, PowerNap is a tool that Dustin created to be able to automatically power, suspend, hibernate, or produce any actions on servers and then automatically power them back on. The tool has been integrated in Ubuntu, and it also works as in a standalone server. However, the usage of this tool can be much more, and it can be deployed in several other places, and it can be extended. We want the server to be in the lowest power state. So
the key about all those, and the key difference between all of those and the traditional suspend, hibernate, and power off actions is that suspend, hibernate, and power off actually takes the system offline. And the only way we have of communicating with it is a wake on LAN packet. So if we have an outside monitor like you can see, we can send a wake on LAN packet and we know we want to bring the system up. However, if we take do some tricks to lower the power state, but still leave the system online, still leave the networking stack up, we can then power the system back up when we detect the right kind of, or the required kind of network activity. And from a server perspective, there are certainly cases where we would like to take the system all the way offline and get 100% power savings. But there may be times where we'd like to get 60 or 70% power savings, but still be listening with the core running and an Ethernet card up.
Sure, depends what your latency requirements are.
Right, exactly. And allow it to fit into maybe more heterogeneous environments, as opposed to an environment where you've got something, a monitor watching over it like a user.
Well, and the other thing that we discussed is currently PowerNap only monitors processes. However, we discussed on how can we extend that and how can we monitor that in some other ways, to monitor a server to be able to produce an action or power off or whatever we desire to do, right? So the idea came by someone else who produced a good amount of code and created monitors. These monitors were a dev input monitor that monitored all the inputs. It also created a monitor for network. It also was a monitor for I/O, and that's pretty much it, right? That's it. So we have those monitors. So the idea of how this goes around is pretty much having monitors running in this way. So PowerNap has an absent period and a grace period. The absent period is where PowerNap does the monitoring, and if whatever we are monitoring doesn't appear to be happening till this point, it enters to a grace period. This grace period, what pretty much does is once the user, hey, I'm about to power off, so I'm going to give you this amount of time before we actually power off or suspend or produce an action. So the idea in the monitors was to create the monitors to basically run all the way. So whenever an action occurs in any time, the monitoring time would be extended and so forth. So we have a process monitor here, we have a network monitor here. So what about when we integrate the actions here, the new way of doing the actions? What personally I wanted to do is just having these monitors process running during the absent time, and in grace period just produce monitors that will prevent the machine from running. But we had a whole discussion about what is the best way to approach, so we decided to just have the monitors either in both times of periods. So so whenever there was an action that prevented the server to be turned off, the period will extend for both the absent period and the grace period. That, from my point of view, that was a little not desired for me. Why? Because if we are about to turn off the server, or power or to take an action, and if by mistake something happened that we don't desire, the time was going to be extended for 300 seconds, for example, in an absent period, and then another 60 seconds. So that would take much more time for the server to actually enter a lower power state.
But what do you mean by undesired action?
For me, okay, for example, what if one of his monitors actually wall packets for every wall packet in the network?
Like on LAN?
Yeah, but those packets don't actually add directly to that, since a wall is just a broadcast.
Yeah, but it's a broadcast with the particular MAC address.
Yeah, but as far as I saw the code that is right now, that actually doesn't compare if that.
The code's
yes.
wrong. The code needs to be fixed.
Yeah, but or for example, what if we had a keyboard connected to whatever server or whatever machine we're monitoring, and happens an action that is undesired. For example, the mouse move or the keyboard or something fell on top of the keyboard, and that produced. Obviously,
it costs you 5 minutes of power, high power time.
Right, and some other thing, in the input monitor, we already proved that the input monitor doesn't work the way it was created for. Why? Because in monitor input, even though there was no keyboard input or mouse input, and there was input in certain periods of time.
So I want to ask Martin about this one. So the fundamental idea, the thing that kicked this off is that we really don't have the concept of or didn't before PowerNap, the concept of a screensaver for a server. Mm-hmm. So just there's nothing going on in the server. Let's save power, and that a screensaver, saves the screen.
But usually you don't have a kind of the concept of a screen in the server, right?
Right, and we're not talking about saving the screen. We're just talking about lowering the power state instead of saving the screen. So we're saving power instead of saving, the things from getting burned into the screen. Okay. So there's a couple of different things that we monitor. For one thing, by default, we monitor processes. So you can define a list of processes, KVM being the example. So if the machine's not running KVM, then that's that server's dedicated purpose. It's not actually doing anything. If it's not running KVM, and it hasn't run KVM for that entire absent period and the entire grace period.
So it has been in the sleep state for all this time.
Right.
Not
So
doing any IO.
Right. So let's lower that. One of the things we decided to add was some primitive monitoring for input, so that if the admin's there and it's about to go to sleep, because you get a wall message that tells you, hey, this machine's going to go down soon, you can hit the space bar and prove to the system that you're awake. And the way we do that is by monitoring dev input and the mouse.
The events. No, basically all the event devices.
Right. So I was wondering if there was a smarter way to do that over dbus or something, or if you know how the node screensaver works, if there's a better way of looking for physical human input on the system.
Well, if you have X running and so on, then it's probably cheaper just to listen to the X event queue, because it amalgates all the different input devices that you have, like power buttons, mouse, keyboard, several buttons.
So what if you don't have X running?
Right. Well, then I think it's really the best just to add a poll to all the dev input events. So just open all of them and just set them to a poll, and whenever something wiggles there, then you get a wake up, and then your monitor can decide what to do about it. So of course, I think you mentioned that you sometimes get input events which aren't really associated to any particular action.
Yes, for example.
Do you have an example what happened there?
Yes, for example, the tool was just monitoring dev input.
I mean, there are certain
and it was monitoring all the events under dev input.
Right, but I mean, of course you will have input devices for keyboards, mouses, and so on, and also power buttons.
So from the developer point of view, from his point of view, from the one who created the input, this works. So he wasn't typing anything, he wasn't using mouse, and it didn't monitor something. So his computer was idled, and there was no event that caused the wake up. In my case, when I put it on 3 of my laptops, there was
server or running desktop.
Running desktop.
Okay.
Yeah, so
The computer was idle and it kept on monitoring and monitoring and monitoring. So then the screen turned off, and it kept on monitoring, and the machine never went to the lowest power state.
Yeah, so perhaps, so I assume what happened is that you got an input event which was attached to, associated to something else than just keyboards and mouse. So for example, we have input devices for headphone jacks. So if you have jack sets, you get an input device that, like, I think is represented as a button event or so. And there is also machines which have these tilt detectors. Like if you move the machine a little bit, then the gyroscope sends events about a different angle, and this will certainly keep waking up. And I'm not sure whether you should actually filter these out. I mean, they're actually useful because then you can check whether, like, your machine is falling down and you want to quickly shut down the hard drive, but I think it's already the BIOS that does that. And the other thing I can think of is if you switch off the monitor, then the input device, then the monitor itself might have some input devices, and these go away, and maybe it picked that up.
Yes,
that's only a theory, so I think in order to debug what actually keeps the machine waking up, you need to run like input events on all the input events devices that you have and see what happens. I mean, otherwise it's just speculation.
Right.
And it probably makes sense to filter those out, like the gyroscopes.
Yes. So the proposed idea to fix this was just using the byte ID. But the problem is here that when we enter to this period, we need a method to actually prevent the system from running. The legacy method, the method that like it was created at first, was just by looking into proc interrupts, and if there was input or mouse for PS2, the machine would be prevented, right? But in this case, that would have been a better way to do this. But
right,
however, this method worked in every machine and out of the box. If we do by ID, we need a way to detect this automatically so that the inputs are got automatically.
So if you are specifically only interested in mouse and keyboard events, then I'd suggest that you use like libudef to iterate or to find all the input devices that you have, and then just look if they've got an ID input keyboard or an ID input mouse.
That's a good idea.
Or like ID input key rather, because so there's keyboard, which is like an actual keyboard, but there's other devices sending key events like the power button. It's just a single key, but it's still a key event which you are probably interested in.
Right.
Like if you have a low power state, you press the power button, you probably want to shut it down completely.
Right.
So I'd watch out for ID input key and mouse. And probably also like ID input touch screen and touchpad and so. You just check whether there's a more generic thing you can watch out for. So if you use libudef, it's a rather convenient API, so you don't actually need to like scan the file system. You just tell it to enumerate all the input devices, and then you just check the properties. And like I can help you with that if you've got a question about this. I've got a couple of example programs how to enumerate various devices in the system. Key, keyboard, yeah, so there's touchpad. Just looking whether there's a common property amongst touchpads, mouses, and so on. Yeah, well, I guess the easiest is to look out for key, mouse, and touchpad. And touch screen, perhaps, if you are so inclined. But I guess at that point, you probably already shut down the screen.
All right, Andres, this is one thing I wanted to bring up because I'm not sure we're looking at the grace period in the right manner. I'm sorry, I wrote these too small. The grace period really shouldn't be it shouldn't be looked at like you were drawing, I don't think, as two different periods. Like this is the absent period, then begins the grace period. I think the only difference is that there should be some amount of time, 300 seconds by default, so 5 minutes. At some point before the action is taken, all we do is throw up a warning. We just throw the wall. And you're still in the absent period. And I mean, at any point in here, we could have taken an activity that would have reset the counter back to 300 and puts you right back into, okay, we got activity. The only difference is that 60 seconds before we take an action, so let's say this is 300, this is 60, and this is 0. The only difference is that we issue the warning, and we use wall to issue that warning. But I don't think that we have any, I don't know, we're hokey, we're server, that's all we have.
No, I was just going to ask where you send the warning to with walls.
It's the best we can do, you know.
Does it also reach to SSH sessions?
Yes.
Okay.
Yep.
Well.
Yeah. So if you're at an SSH session and you're tapping enter, whoa, don't go to sleep, I'm awake. Mm-hmm. If you're at the keyboard and you're tapping, wait, you know, I'm awake. Or if one of the processes that you monitor shows back up in here, it should say awake. And then the new thing is going to be, now that we have this concept of a system that's actually power napping, but still online, you could have a remote machine send a wake on LAN packet and keep you awake.
So do you actually get to know if an SSH session like has a new key event or something? So it quickly woke up to process a key event and then goes down again? Do you catch that?
In the new model or in the old model?
Oh.
In the old model, yes. In the new model, we're still defining what it's going to look like for a system to be. It used to be that a system taking, this is the key difference in our mindset. It used to be that a system taking a power nap was offline, and the only thing that it could do would be respond to a wake on LAN packet. That's the only thing that machine could do. Once you woke it, 5 seconds later, it's back up, it's serving requests and everything. The difference now is that a power napping system is still a functioning system, which gives us all the grand things you can do with the CPU, right? The key difference is that it's actually in a low power state. Now we need to move it back to a full power state.
So low power state means like you still react to, like processes can still run, but you shut down like hard drive and monitors.
Yep. We're going to create, so that's a part of the framework. So Andres is creating a framework where there'll be in user lib PowerNap a set of a bunch of different PowerNap actions that can be taken, and an action has a do and an undo. So power off all CPUs except for one, power on all CPUs, spin down hard disks, spin up hard disks, unload the sound, load the sound.
This sounds like very, very close to what PM Users is already doing. It also has this concept of power saving mode, and so UPower just usually calls it after some period of inactivity. Or if you like call out the AC, then it calls that, but I guess it could just equally well be used for a timeout. Mm-hmm. So it already has some scripts like this, so maybe it would make sense to just plug the scripts there and then just have PowerNap call PM power save on or off, and then you would get all the other bits for free.
Okay. I like the sound of that.
And likewise, of course, if we...
When did PM power save, how long has that been around?
PM power save?
Long time?
Yeah.
Okay.
Maybe, I'm not sure, 2 or 3 years or so.
Okay.
And then conversely, of course, if we have more things to shut down during the power save method, this might also be interesting for like laptops.
Yes, absolutely.
And right now, what we do is like we set the SATA link power management, and we use the HDA, like the sound card, power saving modes and stuff like that.
So the place I use this on desktop computers, laptop computers, are my Myth TV front ends at home. So with PowerNap, I can define that if one of my systems is not running VLC or MPlayer or Zine or Audacious or Rhythmbox, if none of those processes are loaded in my process table and they're gone, they're not in there for this 5-minute period, my systems go to S3 suspend. So they're suspended. When I'm ready to power them back on, I walk up to it, I tap the remote, or press the keyboard or something, they come back up. I've got 5 minutes basically to start watching Myth TV again, right? And then it's up because the whole time that's in the background going, Are you running something? Yep, mem player's running. Yep, m player's running. Yep, m player's running. And then I go to bed, and 5 minutes later my system goes, well, m player's gone. I guess I'm not doing anything anymore. It powers down.
Well, I think this should totally stay in PowerNap. I'm just mentioning that, like, for the particular functionality of shutting down stuff, this could probably tap into PM utils because
Good.
it's already there.
Did you write that down, or should I?
Yeah.
So PM utils and UPower is not set up to do this process monitoring and everything. So this is just
So
to have
that's
in
what
PowerNap.
we keep in PowerNap.
Right.
PM utils.
But I guess that you can just make some use of the PM utils scripts.
That's great.
Well, I guess it sort of happens already anyway, because I guess, I'm not sure whether you install PM utils on servers and have UPower installed, but I guess not necessarily.
We actually depend on PM utils. PowerNap depends on PM utils.
Right.
We use that.
Sorry, go ahead.
We use PM utils to check if S3 or S4 is supported. We use PM is supported.
Right, okay. So that means, so PM utils doesn't do anything by itself, so the desktop UPower calls it when it sees that you like pull out the AC plug and so on.
Okay.
So this would then be, like this trigger would then be PowerNap.
Yeah.
If there is no process running, etc. But
Right. So my key point with this, Andres, is that the absent period, and I don't know if that's the way the code works now, but the more I'm thinking about it, all monitors run all the time.
Right.
All the grace period is the offset at which
Right.
we issue the warning message.
Right. The original way here is like in this point, the keyboard / mouse interrupt monitor worked.
Mm-hmm.
That's the only place.
Right, and I think we should monitor that all the time.
Okay,
We should
so-
never enter the absent period
Right.
if there's input activity on the keyboard. and mouse.
So just to clarify, my idea was like, okay, so let's run another prevention monitor in only this state. For example, we have keyboard mouse here,
Okay.
like only the interrupts one, for example. And then we have here a wall monitor that only runs in this. For example, as in the network point of view, we don't want one wall packets going through the network every 1 minute, 5 minutes. Why? Because it's broadcast. Broadcast goes all around the network, and in big networks, that can create a problem. That can actually be a problem.
Performance copy when
Yeah.
copy is down.
Screw that.
So that was the idea, and for example, when I extended to be able to run an action besides going to sleep, the idea was to keep running these prevention monitors while the action was after the action was taken, which
Okay.
was keeping one core and
Right.
keeping that.
And so the idea there is because those monitors are too expensive to run all the time.
It's one of the ideas is
Yeah.
probably it's too expensive to
Yeah.
run all the
That
time.
was the original reason why I only monitor keyboard during the grace period.
Yeah, and for me it was like, for me it sounded better. Okay, just monitor during grace period. Yes.
So why is it expensive to monitor input events? I mean, it's just a poll.
No, yeah, but the idea was to have different wake-up methods. For example, awake on LAN, or what if ISSH in, and then wake up, like power on turn on all the rest of the cores, or spin up the hard disk, or stuff like
So the
that.
reason why it's
So-
expensive is because this is a power conscious system. We were doing everything we could to be as gentle as possible on power.
Right, I mean, I would expect that it's expensive to monitor processes because you actually have to poll. Also, input devices, you don't have to like constantly go ahead and do anything. You just get a wake up if once something actually happens.
I think he's right. I think we should monitor all the input all the time.
Yeah, at the end I just said, okay.
I mean, if you don't need to,
well,
it's fine, but it seems that the cheapest thing you can do is opening 10 FDs and one poll on them.
Yeah.
And then your process will go to eternal sleep until something happens. Of course, you will get a wake up every time you do something else on the system. So from that perspective, it might make sense to, like, whenever you got a key pressed, then wait 5 minutes until you start polling the FDs again.
So you mean literally?
So that can be
You
optimized.
mean literally the poll?
I think what this thing should do is like you poll, you get an event, then you sleep for 5 minutes, and then you restart the poll. Then you wouldn't get a wake up every time when you're furiously hacking on the keyboard. But if you stop hacking on the keyboard and you have your absent period, and then after the absent period you can poll again.
Right.
So yeah, that you are right. I didn't think about that. It's just that it doesn't cost you anything if there was no input event.
Doesn't cost anything if there's no input.
Right.
Right.
So how do we monitor the processes out of interest? Do you have a clever way to get notifications about that, or do you just call like the CPU state?
We look at the process table for a regex. So the user can define a regular expression of what a process might look like in the process table, and we look at the output of the list of processes.
Okay, but that's polling.
Yes.
Right.
And
And
we
you do this every like 10 seconds or so.
Yeah, it's configurable. Yeah.
But that would mean that you would miss events which only happen like a fraction of the time. Like SSH wakes up for 0.1 seconds to process a key event on the remote side and then goes to sleep again. You would probably miss that.
Well, not really. We're not looking for activity in the process. We're looking for whether the process exists.
Ah, okay.
So if you have a KVM process that lasts less than 10 seconds, yeah, you might miss that.
Yeah, or like if you have like SSH and SCP coming in,
Right.
taking like 3 seconds and then stopping itself, this wouldn't count.
Right. Or you can look for SSHD and then $* which in the process table typically picks up an SSH session that's connected to a TTY.
Right, but I mean like you poll the process table every
Yes.
10 seconds.
Yeah.
So if you do this, 1 second later someone starts SCP, puts a file in the system, SCP stops, and then 5 seconds later you do the next poll. You would never have seen
Right.
the
But
incoming
our default
SCP.
poll is 1 second.
Okay.
It's configurable. It's in the PowerNap comp, but
So that by itself then seems rather expensive. Like if you wake up every second, call the process table, and then shut down again, this seems to draw a lot of power by itself, doesn't
Well,
it?
not really, because you're in a low power state when you're doing that point. In other words, if you have a lot of cores, you can shut down all but one core. If you've got frequency scaling, you can go to the lowest scale.
Okay.
So
Yeah, but it's
a
still
little bit of extra power
Right.
is probably negligible.
where's the process monitor now, Andres?
In the new is a new class, a new module.
It's in
I
plugins.
think about
Yeah, it's the module.
Process
Yeah,
monitor.
yeah, that's a new monitor.
Yeah. So I mean, we're opening proc, looking for each process. As soon as we find one that matches, then we've got a match and we're running something. So it is
It would
really
be interesting to get like an event from the kernel whenever a process starts and stops, so that you don't have to poll, but you can immediately
yeah.
monitor that event and then otherwise do nothing.
Yeah.
Whereas like polling for every second, then this seems rather.
It would be, yeah. It's
Yeah, I'm
one of
just
the,
trying to think about a way how we can intercept the fact that like an exec happens. So like a notification on exec would pretty much be what you want.
right. Like an
Or
identifier
exec or
exec,
so, yeah.
And that would keep us from having to pull the process data.
Yes. Yeah, so I'm just trying to think about whether this such a thing exists or whether it could be added to the kernel somewhere.
Mhm.
Because that would be ideal, I
That'd be
think.
perfect, yeah. Do you think that, but I mean, so I've thought about this a little bit. Back when I originally wrote it, obviously I looked, it didn't exist. The question that I then got was, well then is it going to be more expensive because we got to process events every time the kernel launches something, 99% of which we're not concerned about, right?
Yeah, that's true. You probably need the same model of like subscriber listener thing. So
Yeah.
you would subscribe to these events.
Yeah.
Once you get one, you unsubscribe, wait 5 minutes, and then you resubscribe or something like that. And then the kernel, of course, needs to be efficient enough to see if there are no subscribers, then it doesn't do a lot.
Can you run iNotify on proc?
I don't think you can, but of course it's worth a try.
Yeah, I don't think we can either.
So
Okay.
because proc is not really that kind of best.
Yeah. So
But I think
let's take a
we
to-do.
need something like that, that's true. But of course, stuff in proc changes all the time. It's like FDs and so on, and we are really interested in those. It's just like proc/pid.
PID, right. So I'm going to take a note. We're going to take a look at using poll for input type. We need
Are
to.
you done currently?
A lot of this has changed. I didn't see how the new.
I mean, the new way how things are done.
Oh, Python.
Yes.
Ah.
I mean, the way it does indeed was way simpler, and then Adam, who's wanted to contribute at a certain point of time, he came and did all he modularized everything, and lots of the code he did, we are going to use it, and he implemented some stuff that we actually don't need right now,
Yeah.
like the sleep grace period.
So in the original implementation, I looked at the timestamp on dev input. When that gets modified, then if it's been modified since the last time I looked, then it's active.
But this also sounds like polling.
Yes.
So like polling in the sense you look at the input devices every second or so.
Mm-hmm.
Okay, yeah. So I think this can be made a lot cheaper.
Okay. Well, good. It's Python. You can hack on it.
And here, now that we're running the monitors here, like all the time, like wall, process, or whatever, whenever these produce an action, but it's to lower the power state, which doesn't mean sleep, here we are just going to run some monitors. Why? Because we don't need a process monitor running in the lower power state. We only need the method that will allow the machine to wake up.
Actually, I mean, don't we already have a process which monitors execs and all that stuff, which is called Upstart?
Mm-hmm.
I mean, there must be some way to do this, right? I mean, Upstart tracks PIDs from processes, and even if they demonize themselves and so on. So I think Upstart has a way to monitor execs. So maybe we can just piggyback on that and ask Upstart for such events.
Sure. Upstart for events anytime a process starts?
Yeah, or stops. Would be interesting whether
Yeah.
this tracks and executes.
Because everything's a child init, ultimately.
Yeah, so and it Upstart already tracks them, and it does quite a lot of broadcasting to
Does
devices.
Upstart have that kind of
I
a
think.
library API support?
Yes, it does.
Well, I think Netlink and Gibas is two of those, but of course, I'm not sure whether it has a library, but it's certainly worth investigating whether we could use that instead of polling for processes.
That's what, for example, Ante did for the cluster. He is monitoring processes in HA clustering by using Abstract Vivas API. So
I like the sound of that. I like that a lot. That might be a good thing to look at here. As far as, I don't know what you've agreed to with your professor. By the way, Andres is using this for a senior project. Senior project for school. I don't know what you've agreed to, but I think if you get a couple of actions in and prove that we can save power and put a watt meter on it and see that lower power does mean, or PowerNap lower power state does reduce the power by some significant amount, 25% even.
yeah, I mean, what I agreed is just using the actions, the adding actions. That's the only thing, because when I introduced the concept to him, he showed me the paper that I told you about, and that paper, the only thing it does is monitors and then goes to suspend.
Yeah.
So my idea is compare the power consumption in both cases, using the older paper and using my paper, and do the comparison.
Okay. So
and obviously all the other stuff will be added consequently to.
Yeah. So I think for you guys to succeed at that part, all you really need is to introduce another state below system 3 suspend, and a way of getting it out of that state remotely.
Right.
So if you've got that, I think that's all you need to do. The rest of this is all stuff I would like to do as a good project. And the ideas Martin has given us are excellent ideas.
Right. That's for example. That's why the whole discussion also came around here. Why the way he monitors walls, it doesn't compare the MAC address or anything. So it's just a wall monitor. If there was a wall monitor received by a broadcast, okay, wake up. So
we need to do a string
what
compare.
if I don't want the wall monitor to run during that period, but I do want it to wake it up? So that means that I don't want the wall monitor running here, but I do want it running here after it went to the lowest power state. So that was one of the issues. actually. So, I mean, that's why I try to differentiate between prevention methods and plus, and those also would mean like wake-up methods at the same time, or running the monitor at all times. So if we run the monitor at all times, that means that some monitors will have to run at all times and some monitors will have to run only for wake-up. So if I have a process monitor running at all at times, it produces the action to turn off cores, but I don't want the process monitor anymore, so I have to stop it, but I have to keep the wake command monitor and the input monitor to wake up. And that's the new approach that it was taken, or we are going to take now.
So actually, I'm looking at PM Power Save right now, and I think the bulk of your work then is around getting the waking part to work properly, because it looks like PM Power Save that do most of what we need, and we just might need to add some new, like the other part is to add the smarts that we were thinking about putting into PowerNap. We need to put those into PM Power Save, I think.
Well, it depends. So the monitoring should certainly be in PowerNap, but like the actions, like if you want to shut down a piece of the system.
Yeah.
And well, of course, we need to think about the different use cases here. So right now, the PM rule scripts are meant to keep the system alive as possible. It might slow it down a little bit, like set a link power management. So whenever you do the next I/O, it will take maybe half a second to wake up again. But of course, right now it must only do stuff which reverts itself, so to speak. So if we shut down if you shut down like the Ethernet interface or so, then it's something that wouldn't be appropriate in the default mode. So we then need to have like an additional like environment variable or so, which says, are we actually shutting down power and bringing down the system halfway, or do we just want to conserve power on battery? So there are certainly two different passes. I'm not sure how. So from what I heard, you also want to actually shut down parts of the system which you would normally keep alive on battery.
I mean, it's just like doing it in a sleep, but keeping the network up so that we can wake up, something like that. Like the basic concept.
Yeah, network has to stay up because we're assuming these are remote systems in a data center somewhere that you don't have physical access to go in and wake up like that. So the network is essential. Besides that, as long as the network is up, then we can receive that event. The CPU is processing, our daemon is processing, then coming to monitor. Then if we can just run PM Power Save calls, and that undoes everything, as I understand it, reading the landing page, looks like.
PM Power Save true would be like
to put into the
action that we want to run by default. You pull in the power, pull out the AC power. So that means shut down like USB suspend and USB auto suspend and start adding power.
But if I understand correctly, all those scripts are put under
Etsy, Power, PMD,
right? Or user lib rather. So Etsy is for like
the ones that are
customizations and other stuff. No, they are both enabled, but the package ships in user lib, and the administrator can then tweak them in etc.
So one of the ones that we're most interested in on servers is turning off all the cores except for one.
The cores, that would be quite a nice idea for desktops as well, I think.
So is that something that we could contribute to PM utils, you think?
Fun thing was I actually,
because I mean this is all there is to it, is
I actually tried this in the plane, and I was quite surprised that like with normal four cores I got about 9.5 watts, but if I disable 1 or 2 or 3 I got 16 watts. Something was wrong there.
Yeah, and most of the times we don't need all the cores running.
No, but I mean, I got 6 watt more when I shut down cores, which sounded backwards. But
well, not necessarily. The system was busy.
No, it was idle.
Okay.
So there was something wrong. So I used like the prox CPU active. Right. So you can write like you can echo a 3 into this, and it shuts down with 3 or something like this. Yeah, exactly this.
Yeah.
And I was quite surprised that it did the opposite effect of what I expected.
Yeah. So I mean, we're going to test all of this, obviously,
this would certainly be something which would be interesting on desktop and battery environments as well. So like if you have a load monitor and you have a load above 1, then you certainly want to bring up more processors. But if you have a load less than 1, then
Yeah,
And if it's cheap to start and stop processes, then it's certainly something we also look at. If
But-
it actually helps to save power.
I mean, and it could also be still used whenever there's a UPS running on the server, and the server might be idled or might doing low I/O or whatever. We can, like, if the server is actually running through the battery of the UPS because there was a power outage, we can actually reduce the power of the server itself, but not completely.
That would be another monitor. It'd be a monitor that
Yeah.
monitors the
If
DPU.
we are in UPS, if you're using battery, yeah.
Okay, so how much time we have left? We should probably start
15 minutes.
15? Okay.
I want to discuss something.
Okay.
Okay, so PowerNap has been integrated with Eucalyptus. So basically, the idea works is that we have the cloud controller here, the cluster controller here, and the node controllers here, right? So what it does is Eucalyptus has a database that monitors these servers, and if these servers don't have any images running, it sends a signal, and the PowerNap receives it here and suspends the server. So, I mean, right now PowerNap by itself, without being integrated in Eucalyptus, is pretty much standalone. So how can we integrate this in a data center? How can we integrate in a large network? We might wanna have something like this to probably not to do automatic power suspense or sleeps and wake ups, but we might want it to do like power management remotely from our servers without having to SSH in or without actually having to monitor stuff. Like I had an idea here that was pretty much having a centralized server where power wake is and all the PowerNap and extend the usage of these. More or less like these servers with PowerNap register to these servers, and this server will have a list of all the power, of all the nodes that were running PowerNap. So whenever there is an event that this will cause a sleep, like for example, KVM is not running anymore, or there's no images running. Okay, instead of sending a wall, why not send a message here?
Yeah.
So if there's an administrator, the administrator can just send a wake command packet, and no, keep it up because I want to do something with it. So that's one of the sides of integration. Other thing was like be able to schedule power sleeps in the servers and be able to schedule the wake ups as well, because sometimes we do have servers that we know that from 6 to 9 a.m. we know that there's high load, but from 9 to 5 in the morning, during the night, there's no load in the server. So schedule wake ups and sleeps and wake ups.
At the OS level, because this is possible in the BIOS, but that's so much harder to configure and stuff.
It's just like, it's using the same model. So I have like a database here and says like, okay, turn off at X time. So this will send a signal here, any network packet or network monitor that we can create to do that. And if it receives a packet here, turn it off. The way, something like what Eucalyptus does right now. Right? If not, okay, so this is powered off and we want to wake it up in Y time. So this it's obviously suspended and it has the wall packets will work. So you know what? Send that packet at this time and wake it up.
Yeah.
So and then we can add mechanisms to check if it's up. If it's not up, send another wall packet or stuff like that. And obviously here we will have a list. Okay, these are running and these two are sleeping.
Right. So I mean, what I'm hearing then, we've got a PowerNap, and we have PowerNap D, which is in PowerNap binary package. We have PowerWake, which is the command line interface. Sounds like you want a PowerNap or PowerWake D on the PowerWake server that would communicate with other members of the cluster.
Yeah, I mean, right now, the PowerWake, what does? If you send a PowerWake to this, it will cache the tool. It will cache the
yeah, but it's a
IP
standalone.
or-
It's a standalone program. It runs once and it's done.
Yeah, but I mean, right now we obviously gonna need a daemon that will allow. Okay, turn like for each of the defined nodes, do this or do that.
Right.
I don't think it's likely to be very useful unless it's done in conjunction with any load balancing.
Yeah, well, that was another actually other of my ideas. How can we integrate this in other type of clusters? Because in a load balancing way, it's like, okay, I don't want this server is not with the running anything, so I wanted to turn it off the way that Eucalyptus does. But if my idea is like, we need to extend it to a way that can be used with various other things rather than just load balancers. Because in a load balancer, we can easily integrate that the same way that Eucalyptus does. So in that case, we will need to define metrics on depending on the metrics, do actions.
Yeah. Well, I mean, this is the main reason why Eucalyptus used it the way they did, because they didn't have a good way of sending a message from the system going down. Besides wall, there wasn't a way to send the message. You know, someone contributed a good idea, but a bad patch for sending an email on the way on its way down. Something that seemed like was easy to configure and optionally depend on an MTA. But on my systems, they go up and down so much, I don't want an email every time that they're doing that. But on a server that I expect to only go down twice a day,
So yeah, I mean, the idea could be used like for load balancing, but I don't want to limit the tool for load balancing. So, I mean, there should be another way that we can easily manage power in servers. And I've seen like sometimes actually administrators know whenever there's high load or low load or no load at all in servers, so they might want to turn off the server. So, I mean, for even home routers now, they have that method implemented. So, you log into the router, probably you're outside your house, you log into the router and it says, yeah, I want to send a wall packet to this computer so that it turns out and I can isolate in and do something similar. I don't know if any of you have any other ideas of how to extend a tool to a greater level.
Well, one area that I think you could get a lot of advantage from is on the network, since Dustin pointed out 99% of these machines aren't going to be hooked up to anything except for the network. If you pull one to sleep and you wake up on any network activity, you're going to be waking up on a lot of stuff that doesn't take very much CPU to process. For instance, if you get an ARC, you don't need to come out of your lowest power state, because it doesn't matter how long it takes you to respond to that ARC.
Right.
On the other hand, if you're running Tomcat and you get an RPC, then yeah, you're likely to need that whole machine in order to do it. So you can distinguish between that kind of network traffic and the amount of processing that it takes to satisfy that. Then you ought to be able to stay in deep sleep longer.
Yeah, and that's the idea of defining metrics, but for that, I mean, we probably need a server that captures the traffic, or something that captures the traffic in the network, and that's it. So I don't see an easy way to do that. I've been thinking about that actually. I mean, probably in a NATed network, when the NAT machine knows that there's a packet directed to a specific server, in that case, it could be possible because we will just intercept, oh, there's a packet for there's traffic for this server in particular, let's wake it up. So, I mean, it actually makes more sense to integrate it with load balancers, but I mean, I don't want to limit the tool to load balancing. So that's why I came to the idea of like, what if we just provide a management system of power for administrators? I mean, I don't know if Landscape does it like, but in the future it might be implemented with Landscape. I mean, just I mean, we will list what services are.
Landscape's taking a look at the PowerNap, and I think they've got a large backlog of stuff to do, but they like the concept of being able to provide central management of it. So there's 3 minutes left in this session. Let's capture a couple of outcomes. I think we've got some good information from Martin here that was new input for us, and I think that changes a little bit what we're doing.
So I tried to find out about like what is the monitoring for, but I haven't found out something yet. So it's probably worth talking to Scott and how Upstart does that. I mean, he has looked all, at this stuff from the kernel and Upstart side for literally years. So if it's possible at all, it's certainly no way. This would certainly improve like the process monitoring. But yeah, on the contrast, so the input device monitoring is something that it should very well be possible. Easy to do without pulling, so to make it a lot cheaper.
Okay, so talk to Scott about Upstart, how PowerNap can tap into Upstart to monitor processes in an event-driven manner rather than polling proc. Does that sound fair? Okay.
Well, because the polling proc will both be power inefficient as well as you're going to miss some events.
Okay, so action add any new, well, first of all, let's use PM power save for PowerNap new power save mode, which is fine. We're using PM suspend and PM hibernate, so that's fine. Action contribute new server focused. Well, it's not really server focused. Contribute any new actions to PM utils rather than PowerNap, rather than keeping it in PowerNap.
You want to keep it down like dividing the input polling? So only filter for mouse and keyboard events? And
Yeah, so we need to
use event-based monitoring?
use event-based monitoring for input polling.
I think you also needed to limit it to keyboard and mouse so that you filter out the like gyroscope or whatnot. So the uninteresting events.
Okay, limited to keyboard and mouse. We need to get the network monitor matching the MAC in the wake on LAN. You just gotta look at the wake on LAN spec. I think it's like the MAC address forward and back 600 or something. So
I'm actually surprised that this doesn't happen in the Ethernet class firmware wake on that. I get this.
does, and that works when the system's asleep. But we haven't found a way to get that action when the Ethernet card when the system's up.
So that instead you need to receive for like incoming
Yeah.
Yeah, that makes sense.
So instead, we just have a little network monitor. All right, let's see if Gabi is going to cooperate here.
How do you currently monitor that? You look at the interface state and check the number of received and transmitted packets.
Say that again?
So how do you currently monitor that?
I don't know. How is he doing it? What? We've got a branch with Nearcom.
Like how do you determine whether you got network events?